Question 24, we have a trapezium PQRS. We've been given vector A from P to Q, vector B from Q to R, and we are told that the length of PS is 4 times as long as the length to Q as the length of QR, which basically means that this vector here is going to be 4 times as big as that one. And that's precisely what we have to do for the first question. So find in terms of A and B the vector from P to S. That's going to be 4b. For the second part, vector from P to R, technically it's this journey there, but we don't know any information about how to get from P to R, so we've got to find another route. That route being P to Q first of all, and then Q to R. So for this, I'd write it out as P to Q and Q to R. P to Q is then just A, and Q to R is then just B, which means A plus B is the vector from P to R. R to S. We are looking for this vector here. We don't know it as a direct vector, so we've got to find another way. How we do that is by going from R back to Q, and then we're going to go from Q to P, and then we will go from P to S. So R to Q is B backwards, or the opposite of B. Give us a minus B. Q to P will be the opposite of A. So subtract A. I mean, I'm technically adding a negative A, but I can just write it as a takeaway sum. And then I'm adding 4B to go from P to S at the end. If I do minus B plus 4B, that will give me 3B. And then we have a minus A for that. The point T lies on the line PR such that PT to TR is 4 to 1. So PT to TR is 4 to 1. So roughly speaking, that would be 4 if that's 1. Given that T to S equals KQT, so T to S, that would be this, is KQT, so that will equal K times QT, which is this. Okay, so Q to T. You can see that TS is going to be bigger than it, so TS is so many times as big as QT. We have been given that, so we know that that's true. Find the value of K. Okay, so in order to figure out what K is, that's the end game, then we must be able to figure out what T to S is, and we must be able to figure out what Q to T is. So let's look at them individually. Q to T, first and foremost, the vector from Q to T, that red arrow, that red vector we don't know yet, so we've got to find a way of getting there. We have Q back to P, and then P up to T, which is a fraction of P to R. So just writing this down, we're going to have Q to P, and then P to T. Q to P is minus A, just going back the way here, and then P to T is a fraction of P to R. We use our ratio here, 4 to 1 means that there are 5 parts, so 4/5 of that P to R will be P to T. So we have a minus A for this, plus 4/5 of P to R, which we know from before, A plus B. So I'm going to have negative A plus 4/5 of A plus B. When we break that out, we get 4/5 A plus 4/5 B. And then when the dust settles with that, we're going to end up with negative 1/5 A plus 4/5 B. So that's Q to T. For T to S, we're going to have to go, you've got options here, but I think the simplest one is to go back the way, T to P first, and then P to S. So we'll start off by saying T to P plus P to S. Got that right? No, P to, I wrote T to R here. T to S there equals T to P, then P to S, yeah. T to P is the opposite of P to T, which we just figured out here. So those two terms, The negative of that, if I just write here minus pt, just so you know for sure, but if we plug in our 4/5 a and a 4/5 b, then they both become negative. So I can write that in there. This p to s then was a 4b from before. That was our answer to the first part. And then when I add together the b terms, we will end up with 16/5 of b minus 4/5 of a. So that's what's got q to t and t to s, and basically t to s is so many times as big as q to t. Now most of the time, and this is an example of it, you can have a look at these two and ask yourself how much times bigger is the blue one compared to the red one. And hopefully you can see it, although I've wrote the a's and the b's in a different order. Hopefully you can see that the top numbers of these fractions, actually let me pick a different color, top numbers of these have been multiplied by 4. So the blue one, t to s, is 4 times as big as q to t, and that basically makes your k4. If you didn't spot that, what you'd have to do is basically set these up as a fraction, which isn't the nicest, but if you have this over, I'll write the b's first here, right, as 1/5 of a, like so. Then it'd be a case of, well, all of these are fifths, so if I multiplied everything in the top and bottom by 5, that would become this. And then from there, you've just got to keep simplifying it down. So this is an algebraic fraction. Highest common factor from the top will give us the following, leaving us with something in the brackets that's exactly the same as what we have on the bottom. And then they cancel down from there, and there's our 4. So if you don't spot the number straight away, you can set them up as an algebraic fraction and simplify. Case 4, done.